Okay, new definitions of trig ratios. And again, this is going to carry forward to 30-1, right? So the whole idea, make sure that you know reference angles. Because that concept is very important for trig in 30-1. And make sure that you know these new definitions of trig ratios. So if theta is an acute angle in a right triangle, we know the trig ratios. What's sine theta? So sine theta in terms of these sides is defined as? Yeah, so what's sine theta? Opposite over hypotenuse. What's cosine of theta? Adjacent over hypotenuse. What's the tangent? Opposite over adjacent. However, what's the sine, cosine, and tangent of an angle that's larger than 90 degrees? What's the sine, cosine, and tangent of a negative angle? We need a new definition for sine, cosine, and tangent ratios to address all types of angles. The new definition for the trig ratio of theta, an angle in standard position, involves a point on its terminal arm, the point P, which we'll just give coordinates x, y, right? So there's a point P on the terminal arm, which has a coordinate x, y, and then we have r, which is the distance from this point to the origin. If a vertical line is drawn from point P to the x-axis, then a right angle is formed. If the distance from P to the origin is denoted by r, then by the Pythagorean theorem, okay, so we're talking about, if we have a point here directly underneath, so we've made a right triangle out of the point on the terminal arm, then we have theta, we have y, and we have x. So in this triangle, sine theta is opposite over hypotenuse. The opposite is y, the hypotenuse is r. Cosine is adjacent. The adjacent to angle theta is x, and the hypotenuse is r, and tan theta is opposite over adjacent, or y over x. These ratios, sine theta is y over r, cos theta is x over r, and tan theta is y over x, are the new definitions of trig ratios for angles in standard position. Okay? So we don't want to forget SOHCAHTOA, right? It still comes in handy if we're working a problem that has a right angle triangle. But we need to know, hey, what is the definition of sine, cos, and tan when you're able to rotate anywhere, right? When you have positive angles, negative angles. And here it is, right? Sine theta is y over r. Cos theta is x over r. Tan theta is y over x, where x squared plus y squared is equal to r squared. You made it. Yes. The point -4, 3 defines theta, an angle in standard position. Determine the exact value of sine theta, cos theta, and tan theta. So what should we start by doing?
Sketching it.
Sketching it. Yeah, draw a picture. Figure out, visualize, right? I mean, the whole idea, a lot of the math, right, is just, let's get an idea what this thing looks like. So, draw this, point -4, 3, so x is -4, y is 3. So this is the point -4, 3. Imagine we've got a triangle there. This will be -4, this will be 3. What's this distance here? And this is our angle theta, right? So theta is a positive angle starting at whose initial arm is the positive x-axis, rotating counterclockwise. So that's our angle theta. We have x and we have y, right? I mean, that's given to us, right? So we know that x is equal to -4 and y is equal to 3. So what's r? R is 5, okay? How do you get 5? So x squared plus y squared is r squared, right? So let's do it. X squared plus y squared is equal to r squared. -4 quantity squared plus 3 squared is r squared. 16 plus 9 is r squared. 25 is r squared. R is what? 5. Now you can say r is plus or minus 5, right? You're taking a square root of a fourth root, a sixth root, an eighth root. It's always a plus or a minus. But here, r is equal to 5. So our R value, R value is always positive, right? So r is a distance from the origin to the point on the terminal arm. X and y depends where you are, right? I mean, here, x's are positive, y's are positive, right? Here, the x's is negative. All right, so we need to get sine theta, cos theta, tan theta. Sine theta, the new definition is y over r, which is equal to 3 over 5. Cos theta is x over r. Which is negative 4 over 5. And tan theta is y over x, which is 3 over negative 4. Right, so this is negative 4/5. This is negative 3/4. So using the new definitions, right? Because we no longer have an opposite adjacent. You can't say what's opposite this angle, right? I mean, that angle's over 90 degrees, right? There's no opposite this angle. Okay, so instead we go in terms of, well, we've got a point, x and y. This is how we now define sine theta, cos theta, and tan theta. Okay, any questions? So given x and y, calculate r, use the definition, sine theta is y over r, etc. The point -6, -4 defines theta, an angle, and standard position. Determine the exact values of sine theta, cos theta, and tan theta. Express your answer as a simplified radical. Right? So this time if I say, what's r? You can't just look at it and say, well, if x and y are 3 and 4, then I know that's a 3, 4, 5 triangle, right? So instead we got to say, well, okay, so let's draw a picture. -6, -4 is going to be like down here. So this is the point, -6, -4. This is the angle, right? That's theta. Starting at the positive x-axis, rotating counterclockwise. That's our theta. Okay. We know that x is equal to -6. We know that y is equal to -4. If we want to do sine, cos, and tan, we need x, we need y, we need r. So just go over here, say r squared is x squared plus y squared. So let's flip it around, right? Because it's r we're calculating, so let's just have that on the left-hand side. R, well, you could say r is equal to the square root of -6 quantity squared plus -4 quantity squared, which is the square. Now, the only reason I can say it's the square root of, right? Because I know we're just looking for the positive or principal square root, right? Because r is always positive, right? It's a distance. Distances are always positive. So this is 36 plus 16, which is how much? Which is equal to 2 root 13, right? Okay, so we got to simplify. So express your answer as a simplified radical. So we'll take the entire radical, root 52. Say 52 is 4 times 13, so it's 2 root 13, right? And it's just going to be a positive value. So let's go up here. R is equal to 2 root 13. Sine theta is equal to y over r, which is equal to -4 over 2 root 13. Now I want to get that as a simplified radical. We have to rationalize the denominator. So we're going to multiply by root 13 over root 13. Okay, 2 goes into 4 twice. So up top we've got, well, so its sign is negative, right? Now by sign I mean an S-I-G-N sign, not an S-I-N sign. Okay, so the quantity is negative. We have 2 root 13 over 13. So that's simplified radical form, right? So 2 went into 4 twice. Root 13 times root 13 is 13, right? Because we can't have a radical in the denominator. Right. Now, sometimes there are times where we may want the radical in the denominator, and it's just in the context of the problem we're solving, we need to look at it and say, you know what, maybe I'd be better off having the radical in the denominator here. Okay, but for now, no. Okay. But next year there are situations that you'll be doing where you say, you know what, I'm going to leave the radical in the denominator because I know that something's going to happen which is going to, you know, change that. So when you're working math problems, you get to recognize certain types of problems where you think ahead and just say, this is going to happen, and so I'm going to make a conscious decision at this point to do this. Okay, x over r is negative 6 over 2 root 13. Having a good day. Negative 6 over 2 root 13. So maybe I'll just write that as negative 3 over root 13, and then just go negative 3 root 13 over 13. Right? Like, I don't need to show how I got the simplified radical form, but let me just simplify it first. So we take care of the 2 and the negative 6, and then we know what's going to happen. You're multiplying by root 13 over root 13. You get a root 13 on the top, and in the denominator becomes 13. Tan theta does not require any special work. Tan theta is y over x, which is negative 4 over negative 6, which is 2/3. Right? Positive 2/3. We have a negative divided by a negative. Okay, questions? Nope. So being able to do this, you're going to need to know how to, trust me, this comes up next year, right? Like, you'll be doing this in 30-1. You'll get this situation. I know a point on the terminal arm, and for some reason I've got to figure out sine theta. Okay. How do I do that? I got to get r, and so on and so on. Right? Number 3, if sine theta is negative 5 over 8 and theta is a third quadrant angle, determine the exact value of cos theta and tan theta. Okay, so now they're giving us sine theta. So which quantities are we getting out of x, y, and r? We're getting y and r. And what do we know about y in this case? Negative 5. And we also have another important piece of information here, right? Because when is y negative 5? So think about it. I could have negative 5 over 8. I need a y value of negative 5. It just means I go down 5, right? So I could have an angle here where this is negative something, and this is negative 5, and this is 8. But it could also be here, where this is negative 5, this is positive something, and this is 8. But it's a third quadrant angle, right? So they need to tell us that, right? Because when we go to do cos theta, what do we know about the x value? It's going to be negative. If they didn't tell us, if they just said sine theta, if they just said sine theta is negative 5 over 8, then we would say, well, where is it? Because it could be quadrant 3, it could be quadrant 4. So in this case, we know that it's a quadrant 3 angle. So we get rid of this stuff. So we know that when we work out the x value, we know the x value is going to be negative, right? Because what did they give us? Y and r. What do we know? We know r is always positive. Okay, so y is equal to negative 5, r is equal to 8, and for us, x will be negative. So x will be negative. So if we take x squared plus y squared is equal to r squared and just rearrange it, we get x squared is r squared minus y squared. So in this case, I'm going to leave that as x squared. This will be 8 squared minus negative 5 quantity squared, which will be 64 minus 25, which is 39. So x is equal to plus or minus root 39. So for us, x is equal to negative root 39. Okay, so that's the importance of having to tell us, and they have to tell us, right? If we don't know, then there's two possible values for cos theta, right? X could be positive root 39. And there's two possible values for tan theta, because if x and y are both negative, tan theta is going to be positive. But if they have opposite signs, so if x were positive root 39, then tan theta would be negative. So where you are quadrant-wise affects the sign, S-I-G-N sign, of sine, cos, and tan, which is also a key idea. All right, so we know sine theta, so cos theta is x over r, which is negative root 39 over 8, which is negative root 39 over 8, right? And all I'm doing there is just moving the negative in front. You don't necessarily have to do that. I don't want to see a negative on the bottom, is all, right? So if a quantity is negative and you've got a negative on the bottom, don't leave it there. Either move it up top or put it in the middle. And tan theta is y over x, which is negative 5 over negative root 39, which is 5 root 39 over 39. Okay, so I'm not going to show you how to rationalize that. You know how to do that. You don't really need to show the step. Okay, just simplify it first, and you're multiplying by root 39 over root 39. Right? We can go to rationalized forms. Okay, questions? Okay, so two pieces of information you must have. I know sine is negative, but then, yeah, okay, that tells me that it's below the x-axis, right? And that means quadrant 3 or 4. Now this brings up a very important rule. In each of the 4 quadrants, state whether the trig ratio is positive or negative. Okay, so what this is showing you is x and y. So if both x and y are positive, then what's sine theta? Positive. Both x and y are positive, and what do we know about r? It's always positive. So then cos theta is, and tan theta is. Okay, so take a couple of minutes and fill in the rest of the chart. Okay, so is this good? So this leads to what's called the cast rule. The cast rule is an easy way to remember which ratios are positive in each of the quadrants. So the other problem with the cast rule, so it spells the word cast, okay, which is fine. But it starts down here in quadrant 4. You just got to remember it's cosine is positive, all the sine is positive, and the tan. So there's another way to remember this. And you can go like all science teachers combust. Well, you just have to raise them to the proper temperature, and then they should combust, right? As long as it's not an anaerobic environment, then they wouldn't combust. So then you can start off here, right? ASTC, all science teachers combust. Add sugar to coffee. You know, that's another one, right? So pick your favorite of these. I tend to go with casserole just because I learned that 100 years ago, casserole, right? But, you know, ASTC, this is the way it works. They're all positive. The sine ratio is positive. The tangent ratio is positive. And the cosine ratio is positive, right? Or first principles, right? You're just figuring out, oh, sine is y over r, and I'm above, so the sine is positive if you're above. The sine is negative if you're below. Cosine is positive to the right because x is positive. Cosine is negative to the left. And the tangent's positive when both x and y are negative, right? Quadrant 3. Is that it?
That's it.
Yep.
Seriously?
Yeah.
That's all we're doing today?
I guess.
Really?
He's really using it.
Hang on. I was going to pause